Hello, welcome to this lecture. This lecture is on heat in the work environment and the human heat balance. This lecture is basically talking about how humans or personnel working in a hot environment can survive. This is because the human has its own mechanism of surviving in hot environment or cold environments. That is what we call thermoregulation. The human core temperature is around 37 degrees Celsius. And so at every point in time, the temperature must be at equilibrium. The temperature the body receives should be equal to the temperature the body gives out. And so if the body's temperature, which is supposed to be 37 degrees Celsius, deviates a little bit above or below, then the body will react. And the reaction comes as a result of heat illnesses that comes with it. If the body is not able to release the amount of heat it takes, and these heat illnesses, some are heat rash, which are not as severe, but some goes as much as being fatal. And so if you have a hot environment, the body receives this heat because if the temperature of the environment is higher than the temperature of the body takes in those heats. And there should be a mechanism where the body should be able to release those heats. And if the body is not able to release those heats, it means that we have to put mechanisms in place such that the work environment becomes colder for the body to balance its internal or core temperature, which in totality we call thermoregulation. The body must regulate its temperature. This topic is very important because if you work in a hot environment and we are not able to regulate the temperatures in that environment, it is the personnel that work in that environment that suffers from these heat illnesses. That is what this lecture is about. For expectations for this, we have to know the source of heat in the work environment. That is the only way we can put measures in place or understand the baseline for the heat, so that if there should be addition of other heat, we know how to regulate it or what measures we need to put in place to regulate it. So we need to know the sources of heat, the mode of heat transfer to the work environment. And for our course, we are looking at the mine environment. And for the mine environment, we are looking at the SAP environment, subsurface environment, meaning we are looking deep down in mines or tunnels. And these mines, just like strata gases, which comes from rocks, we have heat coming from rocks as well. And so we have to know how they are transferred. Is the transferal very fast or slow? All those things can give us an information as to how much heat we would have in the work environment and put in the right measures. Then we'll now talk about the balance of heat in human system. The balance of heat, like I have said, if we do not balance the heat, the core temperature to be around 37 degrees Celsius and it deviates totally from these numbers, it will result in heat illnesses, and some can be fatal. And so we would look at those one as well. Now, for the 3 points, we want to look at the sources, how it is transferred, then we look at the heat balance. For the sources of heat in that work environment, we have natural sources and we have artificial sources. We know natural sources, we cannot do anything about it, but it gives us the idea of the baseline of the kind of heat we would find in the work environment before, if there's artificial sources added. That gives us a baseline. So we have the natural sources and we have the artificial sources. With the natural sources, we have two types because we are going to look at the surface environment as well as the subsurface environment. And so when we talk about the surface environment, where does this heat come from? And when we talk about the subsurface environment, where does this heat come from? For surface environment, what we are talking about, it is area above the land surface. It is area above the land surface. And then when we talk about the subsurface environment, they are areas below the surface area of the land. So for the surface environment, the sources of heat comes from surrounding walls of an enclosure. So now let's look at this. For surface environment, it basically refers to the work area above the ground, like I have said, and the primary source of natural heat is from the solar radiation. Solar radiation, like from the previous lectures, we have understood that when the sun's rays hit the surface of the land, there is absorption of heat. And under normal circumstances, some of the heat will be absorbed and some of them would have to be reflected back. But however, it is not just the sun hitting the work or the worker entirely or directly. That is not what it's about. It is how the entire building or work environment soaks up the energy. We have mentioned that there are certain gases in the environment. They will definitely absorb some of the heat and some of the heat would go back. But when it comes to sources of heat in the environment, it is not only about the sun's rays hitting directly at the worker working on the surface of the environment, but how this work area, all the work area, absorbs some of the heat and traps some of the heat. We have surrounding walls, like we have mentioned on the slide, surrounding walls of the enclosure. Let's look at it this way. Let's talk about a building or even a car. Somebody working on a car, the sun rays comes in, hit the worker. That is not the only thing. The person is working in the car. If the car is locked, the sun rays will hit the roof of the car, on the sides of the car, and then trap heat inside the car. So directly it is hitting the car, but the heat is trapped in the car. So that is the work environment. Even if you have a factory and we have roofing sheets, the heat will, or the sun's radiation will hit that environment and trap the heat inside that work environment or that factory. So that is what we are talking about. That is one source of heat in the work environment. And in this case, in the sub environment. And what influences this heat that falls in the work environment or the radiation that falls in the work environment? We have the climate. The climate is one external force that affects the amount of heat in that work environment. So it includes the ambient air temperature, the humidity, the wind speed. So it means that for the heat in the work environment on the subsurface area, the climate or the weather condition has a big influence on it. If it's going to result in heat illnesses or not. For example, a humid climate makes the natural heat feel much worse. Why? Because it prevents sweating from happening. The place is humid, and we know when it is humid, if it's high humidity, means it's getting to the saturation point, and so you are not able to sweat out. And if you are not able to sweat out, it means that the core temperature of the worker is affected, and that can result in heat illnesses. Another factor that can influence the heat that gets into the work environment is the thermal properties. That is thermal conductivity. Would the heat move fast, or how fast does the heat move through the walls? Is the company or the factory you have set the walls made of concrete? Is it made of aluminum? All of that. So the thermal property, that is the thermal conductivity, is it going to move fast? All of them contribute to the heat we feel in the work environment. And that gives us a baseline, because this is natural source of heat. Before you even introduce machines that can produce heat, even the human is a moving engine, a biological engine, because everything the human does produces heat. Just for living, you produce heat. So this becomes a baseline. So that is one of the natural sources when we come to the surface environment. Now, when we look at the subsurface environment, where do the heat come from? What are the sources of heat? We have two main sources of heat. That is the strata heat, and then we have the auto-absorption or auto-compression heat. Now, if we talk about the auto-compression heat, what do we talk about? What about the strata heat? Strata heat is basically talking about the heat that comes from the rock. And then auto-compression heat comes from the fact that there's pressure acting on the air in that work environment. So the pressure that is on the air in that work environment, it is when it's compressed, it produces heat. So these are the sources or two sources of heat in the subsurface environment. And this subsurface environment is below the ground. So drilling down into the crust or from tunnels. These are the two sources of heat that we have. Now let's talk into detail the strata heat flow. From the rock, how does the heat flow into the work environment? Because if heat is trapped in the strata and there's no disturbance, there's nothing, we will not get it in the work environment. But as soon as there is disturbance, just like the strata gases, you disturb and the pressure is released, the gases come into the work environment. The same way the strata heat does not come into the environment, but only come through certain means. That is the strata heat flow. It comes through conduction, convection. So for the conduction, rock layer to rock layer. So the heat moves from one rock to the next before it moves from the rock into the air interface. So the air interface means that it has now gotten into the work environment that we find. Then it gets into the work environment. So from one rock to the next, that is the way that heat from the rock can get into the work environment. Then we have another means, which is the convection. That's a rock to Fischer water. Just like Fischer gases, We have water in crevices, in cracks. So the heat from the rock moves to the water, then now moves into the work environment. This is how heat from the rock moves in the work environment. Again, this heat gives us an idea, the baseline of heat in that work environment. You know the amount of heat that will be in the work environment. And so if it is too hot, you should understand what you need to do to get the temperature cold. Because if the temperature in the work environment is higher than the body's temperature, the heat from that work environment will push into the human. And if the human is not able to regulate it, it ends up into heat illnesses. So magnitude or load of heat from the rock layer or strata is dependent on the virgin rock temperature. What's the virgin rock temperature? Temperature of the undisturbed rocks beneath the earth. So the rock itself has its own temperature. If you do not disturb it, it is there. But how much heat we have in the work environment depends on how much heat the rock has. So for you to understand how much heat you would have in the work environment, you have to understand how much heat the rock, the virgin rock, has. So the virgin rock temperature's heat results from the flow from the core, meaning the core means the deepest parts of the rock. That is where the heat. And like I said, when you are going to the subsurface environment, you drill down into the crust of the earth. And once you move deep into the crust, you get to the core. The core temperature of that rock is very high. And so the temperature will move from the core of the crust, move from layer to layer, then it gets into the work environment. So the temperature of that virgin rock temperature depends on the core of the rock. And very much constant flow of 0.05 watts per square meter. That is the constant flow, the temperature. But it also depends on the rock. How fast, what type of rock? Will it move very fast or not? Very important. Will it move fast into the work environment? So like I'm saying, this is the Earth terrestrial region. That is the image of the Earth. And we are saying that the rock temperature, the temperature will depend on the core, the inner parts of the Earth. That place is very hot. So it depends on that, how much temperature is coming from that. But again, it also depends on the type of rock we have. Does it have high conductivity or low conductivity? That will tell us how fast it will move into the work environment. And so if you have one type of rock that has high conductivity, then we know that it is going to move slowly. The heating becomes slow. And the low conductivity, the heating becomes very fast. So you know how fast the heat will get into the work environment. Then you can make the right decisions, put in the right mechanism so that the people who work in that environment would survive that environment. And that is the variation of the virgin rock temperature with depth. So if you are going deeper, the temperature increases. Like we say, from the crust, you move from the crust, you get into the mantle, outer core, and the inner core. I'm saying that the inner core has the highest temperature. So depending on how deep you excavate into or you drill into the crust, how deep you drill into the earth would determine if you are going to have high temperatures or not. So this graph is telling us that The deeper you go, the higher the temperature. Like we are saying, the virgin rock temperature is a means of determining how much heat we have in the work environment. So the temperature gradient that I showed you, the deeper you go, the higher the temperature. But it also depends on the conductivity, just like I have mentioned. It depends on the conductivity of the rocks. Conductivity just means how fast it flows, the heat flows in the rocks. So higher conductivity means the temperature rises slowly. So it means it has low gradient. Higher conductivity, temperatures rises slowly, and lower conductivity means the temperatures rise quickly. So you have to understand the type of rock you are working with, because the earth crust does not have the same type of rock, different types of rocks. And so for your work environment, and you find a rock that has high conductivity, it tells you how much time you can spend in that environment before the air in the work environment gets very hot. And so if you know that we have a baseline, we know what pertains in or will pertain in that environment. And so if you have to send in hot air, warm, cold air, then you look at it. But one thing you have to understand is sending cold air in such environment is not ideal. Why? Because just like the subsurface environment, when you are moving from the ground level up, the temperature reduces in the troposphere, the temperature reduces. Like we saw when we are looking at the environmental lapse rate, when you move from the ground level to about 1,000 meters, the temperature reduces by 10 degrees Celsius. The same way when you are digging deep into the crust, when you move from the surface, ground level, deep into every 1,000 meters, the temperature would increase. Instead of, if you are going up, it will reduce. If you are digging down into the crust, it would increase. So when you are pushing cold air into that tunnels or underground, while it is going down, the temperature is increasing. What it means is that you are pumping in cold air, but the temperature would increase and increase the temperature in the work environment. So what do we do? So this time, you don't just pump in cold air, you have to send in freezing air, very freezing air, ice. That is what you send in there. So the conductivity of the air, the conductivity of the virgin rock is very important, and that depends on the type of virgin rock or the type of rock you are working with. So like we said, the temperature in the work environment depends on the virgin rock temperature. And so we have to find a way of measuring the temperature. If you measure the temperature of the rock or the virgin rock, it gives you an idea how much heat we will have in the work environment. Then you can make the right decision or put in the right measures. We have the direct way of measurement, and then we have the empirical relationship. The direct way, it means we are going to go into the rock and measure the temperature. But the empirical relationship, it is a calculation. So the virgin rock is equal to 80 plus 90. The D is the depth in kilometers. So the deeper you go, you have the depth you have gone, then you can use it to calculate the temperature of the virgin rock. Now, if we have to do the measurements, what do? We use thermometer, and that is the direct way of measuring it. So you seal this thermometer into a drilled hole. I mean, you have to drill a hole in the virgin rock to measure the temperature of the rock. Or you drill a hole, get a test tube, fill the test tube, put the test tube in the drilled hole. Then you seal the hole, you measure the temperature of the water. That is how you do it. So either you measure, you drill a hole, directly measure the temperature with the thermometer, or you drill a hole, fill test tube, put in the hole, and then you can measure the temperature. So that is the source, the strata heat source that we just talked about. The fact that the strata heat source is coming from rocks, and for the work environment, for you to know exact heat, you have to measure the virgin rock temperature, because the temperature of the work environment depends on the temperature of the virgin rock. And I'm also saying that the virgin rock, the fast way of releasing it, or depending on the type of rock, it will tell us how fast the heat will be released into the work environment. If the rock has high conductivity, it means that it will take time for the heat to get into the work environment. But if you have low conductivity, it will get into the work environment very fast. So that is the strata heat source. Now let's look at the auto heat source. When we talk about the auto heat source, what we are basically talking about is the pressure on the air we have in the work environment. So it's a compressive fluid, that is the ventilation air. It converts potential energy into enthalpy. When we talk enthalpy, what are we talking about? It is the total heat content of the air. That is the enthalpy. So, and it depends on the total heat of the air. So if you have a work environment that is hot, and you feel that, okay, it's too hot, we need to put in or flush the hot air or cool the hot air, and so you are introducing cool air into the environment, like I have said, it will not work, because we all know that the deeper you go, the hotter it gets. And so you put in cold air, while it moves down into the crust, the temperature will rather increase. And that is auto compression heat. It's like you are pressing the air and the air gets hot. That is it. The air gets hot. And this is the expression for enthalpy. Enthalpy and the height. Z is the height. That is the depth of the air, or the depth of the crust you are working in. So from the surface of the earth to the work environment, that's height. That is how you calculate the enthalpy. And I said the enthalpy represents the total heat content of the air. So in the mine shafts, for every 1,000 meter decrease in elevation, enthalpy increases by 9.79 kilojoules. So what it means is that when after every 1,000 meters, the temperature increases, the total heat content of the air increase. And so when you go another 1,000, which makes it 2,000, you're getting close to 20 kilojoules. You go 3,000, just like the surface, when you're moving up, the temperature decreases by 10. This, it increases by almost 10 kilojoules. That is why you have to understand the baseline And the baseline this time is the natural sources of gases in that environment. You know the natural sources of gases. And so when you are going in with artificial sources of heat, which will come from equipment, machines that you are using, then you can calculate or anticipate the amount of heat that will be in that work environment and put in the right measures. So auto compression heat increase in temperature of the ventilation air as a result of auto compression, and it depends on the psychrometric properties of the air. And when we talk about the psychrometry, it's the study of the physical properties of moist air. So the properties of the air is very important, especially the moist air. When you are sending cold air, it is not dry, it has moisture in it. So that property is very important for you to know. Moist air and internal capacity of the air will determine the increase in the air temperature. So it depends on the moisture content of the air. And so when the air is moist and you keep compressing, it's going down, we all know that the temperature would increase by, the temperature will increase by 9.79 kilojoule per kilogram. That's the moisture. So we have the two sources, the strata source of heat and then auto compression source of heat. And these two are the natural sources of heat. Now let's look at the artificial sources of heat. Artificial sources of heat include the machinery, the diesel and electric, example, fans, oils, lighting system, locomotive engines, motors for pumps. Then we have compressed air machinery, because you are compressing some air. Sometimes you want to flush out the air. All that machines that you are using for that generates heat, and that is artificial. It's not coming from rocks or it's not coming from auto compression, because the air is going deeper into the crust. And then the personnel, like I said, the human is a biological engine. Whilst you are working, lifting things, moving, just for living, you are producing heat. And all the heat you produce, you cannot use all. All the heat cannot be used. And so it has to come out. Just a little portion of the heat, about 15%, will be used for your day-to-day activities, for the repair of your tissues and all that. It is only a very small fraction that would be used by the body. So what it means is that if you are working in this environment, you have sources of heat from natural sources and artificial sources. And you as a human, your temperature is supposed to remain at 37 degrees Celsius. And to keep the body active and survive in such environment, there should be a system that should help you to release heat into the environment. But here is the case that the heat in the environment is more than what you have. So usually heat will move from the higher source to the lower source. The heat in the environment will push into the human. That is the reason why you have to put the mechanism, very refrigerated air into that work environment. And in all this, the time weighted average of the temperature must be adhered to. Just like gases, the time weighted average, that threshold must be adhered to. So every time you know that this is the temperature that the human can survive in, and you are trying to cool the air by bringing refrigerated air, you still have to live within the time weighted average. Now, we have to look at the human heat balance, which is very important, because from the beginning of the lecture, if we deviate from that 37 7 degrees Celsius, it would lead into heat illnesses. Several of the heat illnesses, I have mentioned some. So that's the reason why we have to look at the human heat balance. So the metabolic energy results from chemical and biological reaction acting upon consumed nutrients. What it means is that anytime we take nutrient, we eat, we generate some energy. That is the metabolic energy. And this energy is used as heat and mechanical energy, which is less. So this mechanical energy or metabolic energy is made of heat and then mechanical energy. And the heat is more. This heat, we cannot use all the heat in that environment. So, like I'm saying, for the human heat balance, it is very critical for us to understand this. Why? Because it helps with worker safety in hot environments. It helps in worker safety. Like I said, in every hot environment, the human must survive. And so if we do not balance the human heat, then the human is not safe to work in that environment. The metabolic energy that is gotten from food help us to get, or it generates heat and mechanical energy. The heat is more. And parts of the heat must be released into the environment to get the equilibrium or to maintain the core temperature of the 37 degrees Celsius. If the temperature moves beyond the 37 degrees Celsius, it becomes a problem. If you remember, during the COVID, temperatures were being measured. If it is 40 and above, that is dangerous. You are admitted immediately. You go to the hospital, your temperature is around 38 degrees. That is high. Let alone moving to 40 degrees Celsius. That is going to be fatal. You can get heat stroke, heat exhaustion, you can die. That is the reason why we have to look at the heat balance. So for thermal equilibrium, exchange of heat with the surrounding is constant. But here is the case, the work environment has very high temperatures. How do you exchange heat when the environment is higher than the body? No, it will not happen. What rather happen is you will rather get more of the heat that will increase your core temperature. So the metabolic heat, we have, it is used as metabolic heat, mechanical work, and changes in the body, that is for growth. We said the metabolic energy has metabolic heat and then mechanical energy. And we said the metabolic heat is more than the mechanical energy. And for the body to maintain its equilibrium, we have to release some of the heat. Just a small amount of it is used for body growth, for mechanical work, lifting, working, movement, and the heat that the body needs. And that heat is, the temperature is 37 degrees Celsius, just a little of it. The rest must be released into the environment. Now, let's look at the metabolic heat balance. There should be a balance. We have respiratory heat exchange, that is breathing, and the symbol is Q, the convection C, radiation R, and then evaporation E. If we want to have a balance, this is what the loss is. This is what it involves. Now you work. If you work, what do we get? The basic heat balance equation we would look at. So this is what we are saying. There's conduction, there's evaporation, there's work, so many. All this is supposed to help us lose heat from the body. Because when you are producing this heat, and this is just the metabolic heat we are talking about from nutrients, and we are saying that we cannot keep all the heat in the body, but we have to release some of the heat. And if the body needs to release some of the heat and we are still getting heat in the work environment, you can imagine what will happen to the body. And so this is the equation for metabolic heat. This is the generation. And then we have to lose it. We have to lose some of the body. And so we have the S is the rate of heat accumulation. It is important for us to know the heat accumulation. Very important. This M equals to Q plus R plus C plus E plus S is the metabolic heat generation. This is how we generate the heat from the nutrients we get. But the main thing we would want to achieve the equilibrium is to understand the rate of heat accumulation, which is the S. And so if you want to look for S, which is the how much heat we store in the body, then it would be S equal to the M minus the work plus the R plus C plus E minus E. So this is the storage, which is very important. And we expect that the amount of accumulation should always be zero. It should be zero. Because if we keep accumulating this heat, that is what will result in the breakdown of the body to get these heat illnesses. So at thermal equilibrium, no heat accumulation is tolerated. There shouldn't be any heat accumulation. You see the S is cancelled. So what we are saying is that for maintaining or surviving our everyday to-day life, heat accumulation should be zero. If it is zero, you are safe. But if the storage is positive, what does it mean? You calculate and the storage is negative. What does it mean? It's very important that we look at those ones. All the time, the storage should be zero. Positive, it means that there is increment in the temperature of the place. Negative, it is reducing. It is very important that we keep the storage at zero at all time. And in doing this, you have to understand that the thermal or threshold allowable is indicated. The allowable threshold should be a guide. Because if you want to have this equilibrium, but the environment or the work environment does not meet the threshold value, then you will still get positive storage or negative storage, which is not a good thing for the body to balance. All the time, we need to keep it at 0. So this is the metabolic heat balance. So now we understand all the sources and why it is important for us to maintain an equilibrium. And to achieve that equilibrium, accumulation should always be 0. When metabolic heat generation is greater or less than the rate of surrounding environment, removal of heat is needed. 1, the behavioral response to alleviate the situation. Conscious steps must be put in place. Involuntary action taken by the body to re-establish a stable heat balance. All we are saying is that when the metabolic heat generation is greater, what needs to be done? Or when the rate of the surrounding environment is greater, what needs to be done? There are ways of doing it. There are behavioral responses to alleviate the situation. It's conscious steps. You have the generation very high. You know that when the work environment is high, it would affect the body's balance or the metabolic heat generation. And we have also said that the storage should always be 0. So how do we get that equilibrium? If the work environment is too much or is too hot, that is when you introduce freezing air into that work environment. Or the body has a way of re-establishing heat balance. If you live in a cold environment, you would want heat, so you put on jackets. But if the body is hot, you will take off your clothes, meaning you want to release some of the heat. Sometimes when the body is cold, the body will shiver. It's trying to heat itself. So mechanisms are supposed to be put in place in that work environment. What kind of PPEs, especially clothing, are you providing for your workforce in that environment? You cannot allow them to work without clothes, but there should be the type of materials that would help in that work environment. You are an engineer, you know that your work operation would definitely generate artificial heat. You also understand that the work environment is such that the conductivity is very low. So the heat will come into the environment as soon as you start working. What mechanisms are you putting in place? You have to put mechanisms that would help the humans survive in that environment by balancing their temperature and maintaining the core temperature to about 37 degrees Celsius. A behavioral response to alleviate the situation. I have mentioned it, shedding or donning clothes. Shedding clothes means removing it. The temperature is hot, you want to remove it. But in some work environments, you cannot take off your clothes. You cannot. But this is a natural way. You're at home, you're feeling hot, people take off their shirts or wear very light clothes. But not in a work environment like the mines. You can't take off your clothes. So the choice of material is very important in certain work environment. Or decreasing or increasing physical activity. You are feeling hot or you are feeling cold. You can try to walk briskly. That would increase the amount of heat in your body. So these are ways, the involuntary action taken by the body to re-establish a stable heat, and that is referred as thermoregulation. Like I have said, the body is like a thermostat. It has a way of regulating itself. So how do these things happen? The thermoregulations. We have the central core of average temperature. That is the body temperature we have mentioned. The outer layer of the average temperature, the skin temperature. So sometimes you have your blood vessels constraining or expanding to rush blood or to slow down blood. All of them, that is determined by the brains. This is what is happening. Is the pores going to close or open? So the body has its own way of regulating its temperature, but it is not enough when the environmental temperature or the work temperature exceeds what the body can do. And so if it exceeds what the body can do, that is when you put in the measures to help the body to adjust in that work environment. You are working in an environment which is hot and you are trying to fan yourself, it will not work. The brain is telling the body, look, the weather is hot, or my internal temperature is hot, I need to release more heat. But we have a humid environment, you cannot release the heat. The body will now start shutting down, getting the heat illnesses. So now you know that if you are working in such environments, measures are supposed to be put in place. So when the skin temperature exceeds about 36 degrees Celsius, what does it mean? Likelihood of exhibiting the effects of heat strain. So the strain is the effect on the body. The strain is the result of the stress. The stress is the heat that is on the body. So likelihood of exhibiting the effect of heat strain unless subject has been well acclimatized to heat working environment. You know, when you work in a certain environment, like just the environment, the body is able to tolerate to a certain extent of heat. It's able to to the extent of heat, the body is able to tolerate it. And so when it's around 36 degrees Celsius, we can tolerate to a point. Then at skin temperature of 37 degrees Celsius, this is skin temperature. We are not talking about the core temperature. The inner temperature is different from the skin temperature. So the skin temperature at 37 degrees Celsius, then we know there is danger of excessive, of even fatal core temperature. So now you see the two things. When you have skin temperature of 36 degrees Celsius, you will now start feeling the strain. And so the skin temperature is giving an information as to how much the core temperature is. And if you have skin temperature of 37 degrees Celsius, then we know that the core temperature is becoming fatal. The core temperature is 41 degrees Celsius. And I have mentioned that the core temperature should be around 37 degrees Celsius. That is fatal. 41 degrees Celsius and above is fatal. You will die from heat illnesses. There are several of heat illnesses that you can mention. Now let's look at the effect of the heat. So this is the reason why it is important for us to pay particular attention to heat. Not only the gases, not only the dust, they are all parts of what would allow the human to survive in the work environment. And so you can't be working in an environment and only thinking about the gases and the particulate matter in that environment. No, it doesn't work like that. You have to also make sure the temperature of your work environment is within the allowable threshold value. It's within the allowable threshold value. We have also said that there are other factors that would contribute to the severity of whatever environmental factor you are exposed to, like the gas, the particulates. The same way, there are other factors that can influence the effects of the temperature of the environment. Some people will be able to acclimatize and others will not, based on their personal health record. Some people can take it, but others will not be able to take it. Sometimes you go to your lecture halls and if it is very hot, some people may not be able to stand it. They would have to go out because of the heat coming from the body. This time, you are not underground, subsurface. And the materials made of the room is not iron rods, iron plates, or whatever to absorb more heat. It's concrete. But then the heat from the metabolic heat from the people, the heat in the environment coming from the body can also trigger effects to the people in that environment, not everybody. So the effects of the heat, it can be general effects or illnesses. Now the categories we have, some will be short term, some will be long term. Loss of performance, efficiency, and loss of duty time. Yes, you are feeling hot in the environment, it slows down your activity. You are very uncomfortable in the environment. And so the rate at which you have to work slows down. That is short term. Now, let's look at the long term. Loss of performance capability. That's a long term, because if you are in that environment for long, initially you might be acclimatized to it, but with time, it would have an effect on you. The increased susceptibility to other forms of stress. Yes, because now the heat is having an effect on you, so it opens you up to other illnesses. Then reduced heat tolerance. It gets to a point, the little heat, you feel very uncomfortable in that work environment. And that is what would affect your work performance generally. So the effects can be long-term and can be short-term. Now let's look at the heat illnesses. Breakdown of human thermoregulation, that's the illness. And when we say breakdown, what does it mean? It has deviated from the core temperature of 37 degrees Celsius. It has deviated from it. And so inefficiencies in operation of the core and skin temperature receptors, thermoreceptors, it comes from the brain, how it's supposed to regulate the temperatures. That is when there's a breakdown of the human thermoregulation, you cannot regulate it. That is what happens. You cannot regulate your core temperature, you cannot regulate the skin temperature. Not regulating this temperature, what does it mean? It means that you cannot release the heat if needed, or you cannot absorb heat when needed. It cannot do what it's supposed to do to maintain that human heat balance. When there's a breakdown, deviation from the core temperature, the blood flow through the body is affected. Perspiration is affected. You cannot release heat, you cannot gain heat. It's all affected. And when it happens like that, it gets to a point, it can be fatal. That are the effects of the heat. Now let's look at the different types of heat illnesses that we have. We have heat rash, heat cramps, heat syncope, that is fainting, then heat exhaustion, and then heat stroke. Heat is a very dangerous illness that we should pay particular attention to. This is not first aid course. Otherwise, we would have gone into details as to what all this, the effects and all that. You can read on it, but it's very dangerous when you are in an environment that is very hot. When people start feeling hot, you have to move them from that environment totally. Get them into fresh air, especially when it comes to the heat syncope, the heat exhaustion, heat stroke. Those are fatal. They are fatal. You have to take them from that environment, take off their clothes. And it is not good for you to give them hot water immediately. It is not advisable to give them water in those situations. Just take the scenario where we are pushing cold air into a hot environment. If the temperatures are not checked very well, the cold air would, or the cold water you are giving will rather become hotter and have extra effects on the person. So in such situation, the person, you know that the person needs water, you can use your finger in water and rub it on their lips, but not giving them water immediately. Send them to an environment where they can release the heat. So this is the increasing sickness. This is an assignment, but just for your reading, go and review the handout and look at the details. Just look at the effects, but these are the heat illnesses that we should think of. Heat rash, yes, it's not as severe as heat stroke. Heat stroke is fatal. You get to a point, fatal. You get heat shocks. Your body will get confused. The way it is supposed to work is not working. The instructions from the brain would not be followed because of these heat illnesses. So what are the actions that we need to look at when in this environment? So this is a precaution against heat illness. First, design and engineering control of the ventilation and air quality system. Like I said, and now you understand that when you are going deep down, the temperatures would increase. About 1,000 meters from the surface into the crust, it will heat by 9.79 kilojoules. And so you have to have a system that would not increase the temperatures, but rather reduce the temperature. So the engineering, you're all engineers, you have to know the system. Enforcement of threshold limit values for climatic parameters, that is weather parameters, humidity, pressure, temperature, all of them, the threshold limit value must be adhered to. You have to measure the threshold limit values. The availability of cool or potable drinking water. You have to make sure you are being hydrated all the time. These are precautions. Even in the surface environment, you need to drink a lot of water. When the temperatures are high, drink a lot of water. Try to move away from high temperatures. If you don't need to be out, you don't need to be out. These are precautions that you have to look at. Clothing that is appropriate for the work environment and level of activity should be worn by personnel. I have mentioned that the type of clothes is very important, depending on the temperature of that environment. Training of workers to recognize initial symptoms of heat strain and to adopt sensible work habits. It is very important. How will you know that there is strain from the heat. You need to be trained on it. See your temperature. Sometimes you feel you cannot breathe very well. These are all symptoms. You are not sweating, but you know you are feeling very hot, but you are not sweating. This weather is hot and you walk on the sun, you don't sweat at all. That is not good enough. Of course, you can acclimatize to the environment, but temperatures are rising and you are not able to sweat at all. That is not a good sign. It's not a good sign, but it is not conclusive to say that because I'm not sweating, then my core temperature is being deviated from the 37 degrees Celsius. It's not enough. But there are signs. There are signs. So what do you know? You have to move away from your place, drink more water. If possible, go to the nearest clinic to be sure, or the first aiders in your workplace to be sure you are okay. Good dietary balance for workers. You have to eat healthy. So if you go to the mines, they try to feed them well. So it's not about just saying, oh, the mines, you are giving good food. All this thing is planned to ensure that the worker can survive in the mine environment. Workers should have been subjected to process of natural or induced acclimatization prior to being employed in particularly hot conditions. You all understand when you go or leave and you come back, you still have to go back for orientation, you have to do medicals. It is not just for doing sake, they want to be sure you will be fit into the work environment. Very important. So this is the end for the chapter on heat in the work environment and human heat balance. And I have mentioned that this chapter is basically trying to tell us how the personnel can survive in work environments that are hot. And from this lecture, we have looked at the sources of heat. We have also looked at the human heat balance and what we need to. We have enough information to tell us when we need to take in certain precautions to survive in that work environment. Thank you very much.